Okay, so I am now solving a practice question for the LC-3 assembly question, okay? So the first thing that I'm going to do is that I am going to take these numbers and I'm going to copy them into this notepad so that I can make my assessments and conversion on how I should be approaching these problems. Okay, before I do anything about the registers, I'm just going to decrypt the binary format into the assembly code. So when I look at the first four numbers, these are the operation codes. So let me check on the menu on the left, on the instruction set architecture on the left. Let me check what these are. So 0001. 0001 is for add operation. So I'm now sure that these are add operations. All of them are add operations because they all start with 0001. And then when I look at both of the next three bits are the destination registers. So now these three numbers, 010, this 010 corresponds to R2. Okay, let me check the next. This 011 corresponds to R3, right? And then this 001 corresponds to R1. So if you are wondering where these R2, R3, R1, what they are directly the binary conversions of these numbers into decimal. So 010 in decimal is 2. So this is R2, okay? So the next thing that I'm going to look at is, again, the next three bits. When I look at both of these, because it's still possible that the instructions are one of these, right? So I look at the 3 bits here and 3 bits here. This is the first source register, the first operand. So, okay, I'm going to take a look at the second set of 3 numbers. So when I look at all of these, I see R2 for all of these. So I'm just going to write R2, R2, R2. Okay, now I'm looking at the fifth bit. Fifth bit is the distinction between this add operation and this add operation. So I am just going to distinguish them. So when this is 1, this bit number 5 is 1. That means now I'm looking at this instruction. So this one says that the next 5 numbers that I'm going to be looking at are immediate numbers. So, okay. For the first one, this number is, this is 1. This is going to give me 4. That means this is going to be 5. And then in the second one, this 0 is also an immediate number, right? So this is 0 because this is all zeros. And then here we have a 0. This 0 here is, let me see, this 0 here is, because this fifth bit is 0, that means I am going to need to look at the last 3 bits. So the last 3 bits here is 0, 1, 1. That means I am going to take a look at, I'm going to add R3 into this number. So I'm going to add R2 and R3 and write into R1 for this instruction. these 2 zeros are unused. So we are not doing anything with them, because this one here, this bit 5 here is 0. So my instruction actually corresponds to this instruction. Okay. So now in the question, it says that in the beginning, R0 is 0, R1 is 3, R2 is 3, R3 is 4. That's what these numbers are in the beginning. So let's see how they are going to change. Every line is going to change only one instruction, right? Only one value, right? So I'm adding in this line, I'm adding 5 to R2. So R2 equals to R2 plus 5. So as a result, R2 is 8. Okay, so next one. Now I'm writing into R3 and I'm adding R2 plus 0. So I'm copying R2 into R3 in this case. So in this case, R3 is going to be 8 again, because in the previous line, we have updated R2 as 8. Okay, so in the next line, I'm adding R2 and R3 to each other and writing into R1. So R2 plus R3, and the values of R3. So R1 was, it doesn't matter what R1 was. R2 and R3, both of them are 8. So R1 is going to be updated as 16. So eventually, my results are going to be, my answer is going to be, R0 is going to stay as 0 because I didn't change anything with it. R1 is going to be 16. R2 is going to be 8, and R3 is going to be 8.